For centuries, this mountain was not just a barrier. It was a wall that separated entire communities from the outside world. Hidden deep inside the dramatic landscapes of southwestern China, there was a place where a journey of only a few dozen kilometers could take days. Roads disappeared into cliffs, rivers cut through impossible valleys, and enormous stone formations stood like nature had intentionally built a fortress that humans were never meant to cross. Then something happened that shocked even experienced engineers. China decided to do something that seemed impossible. Instead of going around the mountain, instead of tunneling beneath it, they cut straight through it. A giant section of an ancient mountain was literally split open to make way for one of the most ambitious transportation projects in the region. But the real question is not how they cut the mountain. The real question is why they had no other choice, because behind this incredible engineering achievement was a problem so difficult that several traditional solutions failed. The ground itself was unstable, the landscape was fighting against construction, and every mistake could turn billions of dollars of investment into a massive disaster. So why did engineers decide that the only solution was to reshape the mountain itself? And what did they discover inside the rock that changed the entire plan? The answer reveals one of the most extreme battles between human engineering and nature. The story begins in Guizhou Province, one of the most geographically challenging regions in China. From above, the landscape looks almost unreal. Thousands of sharp limestone peaks rise from the ground. Deep valleys cut through the terrain. Rivers flow hundreds of meters below cliffs that seem impossible to climb. This is one of the world's most famous examples of karst geography, a type of landscape formed over millions of years as water slowly dissolves layers of limestone. The result is beautiful, but for construction, it is a nightmare. For generations, many villages in this region remained isolated because nature created obstacles that ordinary roads could not overcome, that a simple trip between communities could involve narrow mountain paths, dangerous slopes, and long detours around cliffs. Medical supplies, equipment, and essential goods often arrived slowly. Economic growth was limited because geography controlled everything. The mountains were not just scenery. They were the reason entire areas remained disconnected. But China's rapid development created a new challenge. The country needed faster transportation networks that could connect remote regions with major cities. Highways and bridges were no longer just about convenience. They became tools for economic transformation, and in Guizhou, engineers faced a decision: accept the mountains as an unbeatable obstacle or find a way to defeat them. The project that emerged was one of the most ambitious bridge constructions in the region, a massive bridge designed to cross one of the deepest and most difficult valleys on paper. The idea looked simple: build a bridge, connect two sides, open a new transportation route. But when engineers reached the actual construction site, the reality was completely different. The first teams arriving at the location faced a rain that looked almost impossible. There were no proper roads for heavy machinery. Before construction could even begin, workers had to create access routes through steep mountain terrain. Equipment had to be transported across difficult slopes. Survey teams climbed through dangerous areas carrying instruments just to understand what they were dealing with. Then came the first major discovery. The mountain was far more complicated than the original map suggested. The ground was not a solid block of rock. Much of the region was filled with hidden geological formations, underground spaces, caves, water channels, the type of hidden structure that can turn a construction project into a disaster. For engineers, this was a nightmare. A bridge of this scale requires absolute confidence in the ground supporting it. Every foundation must handle enormous forces. Every anchor must resist thousands of tons of tension. That a small mistake in geological calculations could create a catastrophic failure. And this was only the beginning. The bridge design demanded incredible precision. The structure needed to cross a huge valley where strong winds constantly moved through the mountain. At this scale, wind is not just a weather problem. That it becomes an engineering force. That a bridge hundreds of meters above the ground must be designed so that it does not dangerously sway. The higher the bridge, the more unpredictable the environment becomes. Below the construction area, rivers created another challenge. During normal conditions, mountain rivers may appear calm. But during heavy seasonal rains, those same rivers can transform into powerful currents capable of damaging structures and changing the landscape. Building support pillars directly inside the valley seemed like the obvious solution, but the environment made that option dangerous. The river could threaten the foundations, the unstable slopes could create landslides, and the underground geology made every excavation uncertain. The engineers were running out of traditional answers. Point one option was to move the entire route. Maybe another location would provide better ground. But every alternative revealed new problems. The surrounding mountains were even steeper. The valleys were deeper. The construction would become longer and more expensive. Another option was building tunnels through the mountains. But drilling several kilometers through complex karst rock would take years, possibly decades. The cost would explode. The dream of connecting this region quickly would disappear. Then engineers faced the biggest obstacle of all. The mountain itself, a massive rock formation, stood directly in the path of the planned route. IT was not just blocking the road, IT was interfering with the entire design of the bridge system. A suspension bridge depends on precise forces. The cable supporting the roadway must be positioned at exact angles. The anchor points must be incredibly strong. The entire structure works like a carefully balanced machine. Changing one part affects everything else. The mountain was positioned exactly where engineers needed their system to function. Going over created unstable geometry. Going around it destroyed the efficiency of the design. Going beneath it was too expensive. And that is when the most extreme idea appeared. The engineers proposed doing something that sounded almost impossible. Instead of fighting the mountain, they would reshape it. They would cut through it. The proposal was simple to explain, but terrifying to execute. Create a massive opening to the mountain so the road and supporting systems could pass through a human-made canyon inside an ancient natural structure. AT first. Even experienced specialists questioned the idea. Mountains are not ordinary obstacles. They are the result of millions of years of geological processes. Changing one could create unpredictable consequences. What if the rock collapsed? What if the mountain became unstable? What if removing part of it triggered a chain reaction? The risk was enormous. But after analyzing every option, engineers concluded that the controlled removal of rock was actually safer than forcing a design that the landscape could not support. The mountain had to be opened carefully, not destroyed, controlled. And that difference was everything that a normal explosion would never work. A massive blast would fracture surrounding rock and create an uncontrolled collapse. SO engineers used precision excavation techniques. The process involved carefully planned drilling, controlled blasting, and constant monitoring. Instead of breaking the mountain apart randomly, they created a precise separation line. Every section removed had to follow engineering calculations. Every movement of the rock had to be monitored. Sensors tracked changes. Engineers watched for even tiny shifts, because inside a mountain, small movements can become huge failures. Workers also had to deal with the enormous amount of material removed. The project created millions of tons of broken rock. Normally, this would become a disposal problem. But engineers turned the challenge into an advantage. The extracted stone was processed and reused. The material became part of construction operations, reducing waste and transportation requirements. The mountain that had blocked the project was now helping build it. And then came the moment everyone was waiting for. The artificial canyon was completed. The mountain had been opened. But the reason behind this decision was far more advanced than simply creating a passage. The opening allowed engineers to solve the bridge's most difficult structural problem. The supporting forces could now follow the correct path. The massive cables could be anchored deeper into stronger rock. Instead of relying on unstable outer layers, engineers reached more reliable geological formations inside the mountain. The mountain itself became part of the solution. This was a hidden genius of the design. Humans did not simply overpower nature. They studied it. They found its weaknesses, and they used its own structure to create something stronger. The bridge also had to survive another invisible enemy, the wind. At extreme heights, air movement becomes a serious engineering challenge. The structure needed to reduce resistance and remain stable during powerful gusts. Engineers designed the bridge components to handle these forces, allowing wind to move through the structure instead of pushing against it like a giant wall. The region's earthquake risks added another layer of difficulty. Southwestern China experiences significant geological activity. A structure built here can not only survive normal conditions, IT must survive the unexpected. That meant every connection, every foundation, and every support system had to be designed with movement in mind. After years of calculations, construction, and problem solving, the impossible structure finally became reality. A bridge now cross a landscape that once seemed impossible to connect. The journey that once required dangerous mountain paths became a short drive. Communities that had been isolated gained access to faster transportation. Businesses gained new opportunities. Tourism expanded, and the region began changing. The bridge became more than infrastructure. IT became a symbol that geography does not always decide what humans can achieve. Sometimes humans decide how to negotiate with geography. Today, visitors come not only to travel across the bridge, but to experience the scale of what was created. They stand above the valley, they look down into the landscape, and many still struggle to understand one simple fact. A mountain that existed for millions of years was changed in order to create a road for the future. But perhaps the most fascinating part is not that engineers cut through a mountain. IT is that they waited until they understood the mountain well enough to know exactly where to cut. Because the greatest engineering achievements are rarely about destroying obstacles, they are about understanding them. And in one of China's most challenging landscapes, the solution to crossing a mountain was not to escape IT was to open it.